Hello students, today we are going to learn 6th chapter in NCERT textbook Electromagnetic Induction. You might have already studied about magnetic effects of current, which was the 4th chapter, which is given in the book as moving charges and magnetism. From this chapter, you would have learned that when current flows through a conductor, a wire, then a magnetic field is produced around it. When current flows through a conductor, for example, let me say this is a conductor. When current flows through this conductor, a magnetic field is produced around it. This was discovered by Oersted. This was an accidental discovery that flowing current producing magnetic field, because till then people thought that magnetism is a bulk property. For example, you have a magnet with the north pole and south pole, and this bulk matter like lodestone, they have this characteristic property of magnetism. Now, later it was Ampere who found that it is not just bulk property, it is atomic property. That is atomic magnetism. It arises due to the charges revolving around the electrons, revolving around the nucleus. So, this connection of the atomic magnetism led to the idea that the moving charges, which is current, produces magnetism around that particular wire or conductor. You would have learnt about Biot-Savart's law, Ampere's circuital law. I am not touching that. I have short videos in English before that. As I said, this is going to be a video in both English and Tamil. நான் என்ன பண்ண போறேன்னா இந்த டாபிக் electromagnetic induction I am going to teach you in both Tamil and in English. So let us start with electromagnetic induction. In the electromagnetic induction என்ன ஆக்சுவலா இது opposing effect of, this is opposite to that of magnetic effects of current. See, magnetic effects of current, you would have studied in class 10th standard, effects of current. That is how the current is producing magnetism or magnetic field, that it is just opposite to that, and that is electromagnetic induction. இது just opposite to that. This idea was thought by Michael Faraday. Now, let me tell you how did he get this idea, how the thinking of Michael Faraday led to the idea of electromagnetic induction, and the application of it is mainly you will find in a AC generator. Generator we use now whenever there is no electricity, we use generator. So that is based on the principle of electromagnetic induction. And how did Michael Faraday arrive at this idea? For example, consider a wire, a loop, a circular loop of wire. Now, let us say a small bulb we will connect, right? We will connect a bulb. LED, you can imagine. Remember, there is no source of electricity here. There is no cell, there is no battery. It is just a piece of a circular loop like this. That's all. There is nothing in this. Imagine here there is a small LED is there. So that we can know what is going to happen. Now, what Michael Faraday did, he brought a magnet. This is a permanent magnet with the North Pole and South Pole. Whenever you say there is a magnet is there, magnetic field will be around it. How does the magnetic field act? It starts from North Pole and it comes to South Pole and closes here. And a magnet is a dipole. It always will be in North and South Pole. How many times you cut it, always it will have North and South until you go deep into the nucleus and the electron revolving around it. Till then you can break it and come to that. That is where atomic magnetism, the concept of atomic magnetism arose. Now, let us say the magnetic field is acting, but it starts from North Pole, ends in South Pole. We can't say like that. It will continue and it will be like a continuous, like this, a loop. So now if I take another North Pole from here and take another field line, right, it starts from North Pole, ends in South Pole. Now when I take another line like this field line, let us say, now you will find that again inside the magnet it will be North Pole to South Pole. So let me take one more for our reference now, right, and another one this side let me take, yeah, and we can have more like this, right? Here it is coming in, so arrow will be inside, and here it is going out and the arrow will be moving outward direction. Here it is moving outward, and in the South Pole they all are coming inward. They all are coming inward. So, this is the basic magnetic field. Magnetic field is represented by the symbol B. Electric field is capital E, magnetic field is capital B. Now, what we are going to do? We are going to move this magnet into that loop, right? When I move this magnet into the loop, what will happen? The magnetic field will get disturbed. We say the magnetic field will get cut. Now, magnetic field is getting cut. Where is it getting cut? It is cut in the loop area. That means in this area. So, let us say the area of the loop is going to be capital A, let us say. And the magnetic field is B. The product of B into A, the magnetic field into area of the loop, gives you a term called magnetic flux. Magnetic flux. Magnetic flux is the number of field lines passing through a particular area. This is a very important concept, just like electric flux. So the magnetic flux is going to change. The magnetic flux is going to change. When the magnetic flux changes, you will find that the electrical charges, the charges inside the wire will start moving. When they start moving, we say current is produced or current is induced. So, the current will be induced, let me say just like this. I am drawing the direction of the current just like that, not specifically. When the current flows through that, you will find that the bulb will or the LED will glow. Now, what we understand from that is the change in the magnetic flux is inducing an EMF. In those days, the word EMF, the electromotive force, though we should not split it EMF only we should say, whose equivalent nowadays is potential difference, not totally equal. Little we will understand about it from current electricity. Now EMF is induced. We say the EMF is induced. Okay. When EMF is induced, naturally there is a cell, let us say this behaves like a cell, and in cell when EMF is there, then the current will flow through that. So that current we call it as induced current. Induced EMF, and another word you will come across is induced current. So இதுதான் கான்செப்ட். டு இன்டியூஸ், இன்டியூஸ்னா என்ன ஆக்சுவலா? தட் இஸ் ப்ரொவோக், தூண்டுறது. என்னது தூண்டுறது? இந்த மேக்னெட்டிக் ஃபீல்டு இருக்கு இல்லையா, இந்த மேக்னெட்டிக் ஃபீல்டோட அசோசியேட்டட் ஃப்ளக்ஸ் இருக்கு இல்லையா, அது இங்க தூங்கிட்டு இருக்கிற எலக்ட்ரானை தூண்டுறது. கம் ஆன், கெட் அப், மூவ், ரைட்? Then the electron starts moving, and that is causing a induced EMF. That is why it is called induced EMF. Now who is provoking? Who is making that to happen? That is change in magnetic field or magnetic flux. More precisely, the word is flux. Okay, the change in the magnetic flux induces a current. Induces, அதாவது தூண்டுறது. இப்ப நீங்களாம் இருக்கீங்க, எக்ஸாம் எழுதுறீங்க, 12th ஸ்டாண்டர்ட். அந்த எக்ஸாம் போர்டு எக்ஸாம் இல்லாட்டி நம்ம படிப்போமா? போர்டு எக்ஸாம் இருக்கிறதுனால தானே நம்ம படிக்கிறோம். அப்ப அந்த போர்டு எக்ஸாம் இருக்கு இல்லையா, அதுதான் நம்மள தூண்டுறது, அதாவது நம்மள இன்டியூஸ் பண்றது. நம்ம படிக்கணும், நம்ம எக்ஸாம்ல நல்ல மார்க் வாங்கணும். இது எதுக்குன்னா, அது who is inducing it? somebody is provoking it. அந்த ஃபேக்டர் தான் இந்த மேக்னெட். Now I'll show you a small demonstration. For example, right now I have a circular loop, right? Imagine I have connected a small LED bulb here. Now I bring a magnet. This is a magnet. Imagine magnet is having north pole and south pole. So what I do, I bring this like this, like this, like this. Imagine that magnetic field is around it, right? As I bring it closer and closer and closer, what will happen? The magnetic field lines will get cut. That means magnetic flux will change, and the loop is having an area. அப்ப என்ன ஆகும்னா, this circular loop will become a magnet. இந்த சர்க்குலர் லூப் ஒரு மேக்னெட்டா ஆகும். அப்ப மேக்னெட்டா ஆச்சுன்னா அப்ப என்ன ஆகும்? அதுக்கு நார்த் போல் அண்ட் சவுத் போல்னு இருக்கணும். இந்த ஒயர் லூப்புக்கு எங்க நார்த் போல் இருக்க போறது, எங்க சவுத் போல் இருக்க போறது? That you will find that this particular part, this side of the loop will become north pole or maybe south pole. When this becomes north pole, the other part will become south pole. இப்ப head and tail இருக்கு இல்லையா? இப்ப இது headனா naturally the other part will be tail. இது tailனா இது head-ஆ இருக்கும். அப்ப நான் நார்த் போல இதுக்கு எடுத்துன்னு போறேன், இங்க இந்த லூப்க்குள்ள இன்சர்ட் பண்றேன். When I do that, as I do that, the magnetic flux is changing and the bulb will glow. That means EMF is induced and current is induced. The induced current is flowing through the coil. இப்போ உங்களுக்கு புரிஞ்சிருக்கும்னு நினைக்கிறேன். இந்த மேக்னெட் இருக்கு, இந்த மேக்னெட் இந்த காயில்ல கரண்ட்டை இன்டியூஸ் பண்றது. அதை தான் நம்ம electromagnetic induction, to induce the magnetic field and the wire and create electricity, electromagnetic induction. சரி, that's okay. அப்ப என்ன பண்ணாருன்னா, Faraday, he brought two laws for that. So, how do you define first electromagnetic induction? That is, whenever the magnetic flux across a coil changes. Whenever magnetic flux across a coil changes, an EMF is induced, which induces a current, and that current is called induced current. This is the definition of electromagnetic induction. That is, whenever the magnetic flux across a coil changes, an EMF is induced or an EMF current is induced. That is as simple as that. Now, Faraday's first law. Faraday, he put this into two laws. So, let me first erase all these things I have now drawn on the board, right? So, the topic you have to keep it in mind that electromagnetic induction. Electro means electricity, magnet means magnetism, and induce. Magnetism inducing the current. That is called electromagnetic induction. Now, Michael Faraday, this Faraday's laws, we call it as Faraday's laws of electromagnetic induction. There are two laws. What is the first law? First law is very simple, the same definition of electromagnetic induction. Whenever the magnetic flux across a coil changes, an EMF is induced or an EMF current is induced. That's the first law. Now, we have the second law. The second law என்ன சொல்றதுன்னா, what is the magnitude of the induced EMF? அதை வந்து எப்சிலான்னு சொல்லுவோம். எப்சிலான். இது வந்து பெரிய எப்சிலான், பிக் எப்சிலான். இது வந்து சிம்பல். இந்த எப்சிலான் is equal to, how is this EMF induced? The EMF is induced because of change in magnetic flux. So, d phi by dt. When you say change in magnetic flux, it is with respect to time. It varies with the time. So, d phi by dt. This is Faraday's second law. But there is a small hitch here. You will find that there is a negative sign in front of it. In the negative sign, inge vandu varudhu. We know EMF is induced, maybe 1 volt, 2 volt, 3 volt, maybe 1 ampere current, 2 ampere current, 3 ampere current. அது ஒரு பக்கத்தில் இருக்கட்டும். அது ஏன் induce ஆகிறது? Who is inducing? The magnetic flux is inducing. Right. So, rate of change, அதுவும் change ஆகணும். இது வந்து இப்படி suppose stable இருந்தது, stationary இருந்ததுன்னா nothing will happen. It has to change. As you move, then only that rate of change will induce the EMF. But you see, there is a negative sign. This negative sign is very, very, very important. This negative sign gives you the direction of the induced current. இப்போ இதில் வந்து induced current வரப்போகிறது. இந்த induced current clockwise-ல இருக்கலாம், இல்லாட்டி anti-clockwise-ல இருக்கலாம். இது clockwise-லையும் இருக்கலாம், anti-clockwise-லையும் இருக்கலாம். இது clockwise-ல இருக்கும், anti-clockwise-ல இருக்குங்கிறது நமக்கு எப்படி தெரியும்? அதை வந்து we are going to learn now. Why it should be clockwise or anti-clockwise. You might have learned in class 10th. Let me erase this and give you an idea about clockwise and anti-clockwise direction. Clockwise, இப்போ வந்து clockwise-ல current போச்சுன்னா, அந்த side will become south pole, right? This will turn south pole. Suppose இதே இது வந்து anti-clockwise-ல போச்சுன்னா, இப்படி வந்து opposite, anti-clockwise-ல போச்சுன்னா, that will be north pole. That will be north pole. You might have studied this concept in the class 10th. ஒன்று வந்து clockwise direction is south pole and anti-clockwise direction is north pole. இதை வந்து மைண்ட்ல கிளியரா வச்சுக்கணும். Right? I will show you now. Now you see, north pole is there. Now north pole is coming towards the coil. இந்த side வந்து, this side, should it be north or should it be south? இது வந்து north, இது என்னவா இருக்கணும்? அது எப்படி டிசைட் பண்றது? இது நார்த்னா, இப்போ இது சவுத்னா என்ன ஆகும்? நார்த் will get attracted towards south. நார்த்னா இங்க வந்து நார்த் இருக்கு, இங்க வந்து சவுத்னா அது வந்து அதாவே அப்படியே உள்ள போயிடும். Suppose if that is the case, if this part becomes south pole, now I bring the magnet, I just hold it, by itself it is going. It is very, very, very contradictory to law of conservation of energy. Law of conservation of energy says energy can be neither created nor destroyed. That is a general statement. But it can be transformed from one form to another form. நான் வந்து இதை நார்த் போலா வச்சிருக்கேன். இங்க சவுத் போல்னா இது வந்து அதாவே அட்ராக்ட் ஆகுது. அப்படி அட்ராக்ட் ஆச்சுன்னா what is the meaning? நான் ஒர்க்கே பண்ண வேண்டாம். Without me doing any work, by itself it will create electricity. By itself it will create electricity. Without me doing work, electricity is created. Without me studying for the examination, I get in physics 70 out of 70. Is it possible? Possible. No, it is not possible. So, if this is a north pole, this ought to be north pole. This side ought to be north pole. ஏன் இது north pole இருக்கணும்னா, north pole will repel. When it repels, then I will do work. That work I do by pushing it, by doing the work, by pushing that, what will happen? The work, that is mechanical energy. That mechanical energy is moving and converting that into electrical energy. That is, mechanical energy of motion is moved and changed into electrical energy. அப்ப electrical energy, அது வந்து law of conservation of energy, according to that, it holds good that one energy is transformed into another energy. So it obeys law of conservation of energy if this is north pole and this should be north pole. If this is north pole, what should be the direction of the current in this? What should be the direction? Anti-clockwise. Number, we can find out the direction of the current from that only. Now you see here, right? Now, if I bring north pole here, if I bring north pole here, and you will find that this also will be north pole. அப்ப என்ன ஆகும்னா, நான் நார்த் போல் இங்கே எடுத்துட்டு வந்தேன்னா இதுவும் நார்த் போல் ஆகும். இது நார்த் போல் ஆச்சுன்னா ஆன்டி கிளாக்வைஸ் டைரக்ஷனில் இந்த லூப்பில் electricity will be induced, current will be induced. If this is the north pole, then opposite to that is south pole naturally. If one part is north pole, the other end will be south pole. North pole, south pole. So, I hope you understand. That is why the direction, the negative sign is here. This idea is given by Lenz. There is another scientist by name Lenz. We call it Lenz rule. According to Lenz rule, the direction will be decided. Now I will tell you what is Lenz rule. Before that, suppose I change the system now. This is south pole and இது வந்து என்ன ஆகணும்? சவுத் அப்படிங்க வரணும்னா இதை ரிப்பல் பண்ணணும். இப்போ ரிப்பல் பண்ணணும்னா இது வந்து சவுத் போல் ஆகணும். அப்ப இது வந்து சவுத் போல் ஆகும். இப்போ இது சவுத் போல் ஆச்சுன்னா என்ன ஆகும்? இங்க வந்து கிளாக்வைஸ் டைரக்ஷன்ல கரண்ட் இருக்கும். இப்போ இது கிளாக்வைஸ் டைரக்ஷன் அப்படி பார்க்கும்போது இருந்தா இங்கேருந்து பார்த்தா இது வந்து ஆன்டி கிளாக்வைஸா இருக்கும். இது வந்து நார்த் போலா இருக்கும். இப்போ வந்து இது சவுத்துனா இது சவுத்து, இது நார்த்துனா இது வந்து நார்த்து. And why this is important, that only will decide the direction of the induced current. So keep that in mind. Okay, that only decides. Now this negative sign I am going to explain, and I am going to teach you now Lenz rule. Okay, now I'll teach this is the last concept for today's in this video, right? And I am going to now tell you how this negative sign is having implication, and we are going to study about Lenz rule. Lenz rule. Now, Lenz rule gives you the direction. So we know epsilon is equal to minus d phi by dt. That is, rate of change of magnetic flux induces an EMF or induces a current, and the direction of the current is opposite. So what Lenz rule says? It's a very interesting rule. Now, this wire, the electrons are sleeping. Electrons வந்து சும்மா இருக்கு. அதாவது external, that means valence electron, free electron, அதுதான் மூவ் பண்ண முடியும். Atom, இது வந்து made up of copper wire. Okay, it is made up of copper atom. Whole atom will not move. Atom positive nucleus inside shell, nothing will happen. It will not be disturbed. The positive ion will be there. Only the outermost electron. These electrons in physics are called free electrons. When you apply an external field, only these free electrons can move. In the whole positive ion is immobile. இது மூவ் பண்ண முடியாது. மேக்ஸிமம் அப்படியே கொஞ்சம் வைப்ரேட் பண்ண முடியும். ஆனால் எலக்ட்ரான்ஸ் இருக்கு இல்லையா, லைக் அ clouds it can go. It can move together as a, when you apply some battery or voltage, because of that electric field it will move. So இந்த எலக்ட்ரான் இந்த வயர்ல சும்மா தான் இருக்கு. ஆனால் இந்த magnet, when it comes here, it says, come on, get up, come on, come on, come on, get up. You start moving. When it starts moving, when electrons move, that is called electricity. That is current. Okay, that is the induced current. So it is inducing. Who is inducing? This magnet, this magnetic field, this magnetic flux. But this electrons are so horrible. What it says? You are telling me I am sleeping nicely. You are waking me up. Yes, I will oppose you. I will oppose you. எப்படி நான் எப்படி வந்து எதுக்க போறேன் அப்படின்னா, இங்க நார்த் போல் வரும்போது இங்க வந்து நார்த் போல் ஆறுது. அப்ப நார்த் போல் ஆகும்போது ரிப்பல் பண்றது இல்லையா, அது ரிப்பல் பண்றது. So Lenz rule says the direction of the induced current, the direction of the induced current is such that it opposes the cause that produces it. Come on, come on, come on. Beautiful sentence. The direction of the induced current, anti-clockwise, north pole, is such that it opposes the cause. Who is producing this current, induced EMF in the magnetic field, magnetic flux? அதை அப்போஸ் பண்ணும், அதை அப்போஸ் பண்ணும். அதனால தான் இந்த நெகட்டிவ் சைன் இருக்கு. இது it is given by Lenz rule. It's very simple statement. The direction of the induced EMF or current is such that it opposes the cause that produces it. And this is in accordance with law of conservation of energy. Right? It's a very famous 2-mark question. சுவாமி விவேகானந்தா சொல்லுவார், நம்மளை நம்ம அப்பா அம்மா தான் வளர்க்குறாங்க, நமக்கு படிக்க வைக்கிறாங்க, நமக்கு சப்போர்ட் பண்ணுறாங்க. ஆனால் ஒரு ஏஜுக்கு அப்புறம் என்ன ஆகும்னா, ஒரு காலேஜ் டைமில், ஸ்கூல் 10th 11th 12th போது நம்ம அப்பா அம்மாவே எதிர்ப்போம். அவங்க தான் நம்மளை ப்ரொடியூஸ் பண்ணாங்க, அவங்க தான் நம்ம இந்த உலகத்துக்கு கொண்டு வந்தாங்க. ஆனால் நம்ம என்ன பண்ணுவோன்னா, எங்கள் அப்பா சொல்கிறது தப்பு, எங்கள் அம்மா செய்கிறது தப்பு அப்படின்னு சொல்லுவோம். இது ஒரு நேச்சுரல் லா, இது ஒரு விதி. இந்த விதி, இயற்கையின் விதியை மாற்ற முடியாது. அதே மாதிரி அது ஏன் அப்படி நடக்கிறதுனா அது சொல்ல முடியாது அதை பற்றி. ஏன்னா நம்ம க்ரோ ஆகிறோம் இல்லையா, அப்போ நம்மளோட தாட் ப்ராசஸ் டிஃப்ரெண்ட்டாக இருக்கிறதுனால நம்ம அவங்கள ஃபஸ்ட்டு எதிர்ப்போம். அதுக்கப்புறம் ஒரு பாயிண்ட் லைஃப்பில் வரும், நமக்கு தெரியும், ஓ நம்ம அப்பா அம்மா நமக்கு நல்லது தான் சொன்னாங்க, ஆனால் அப்போ நமக்கு புரியல, ஏன்னா அந்த வயசில் எனக்கு புரியல அப்படின்னு நம்ம நினைப்போம். அதே மாதிரி அதெல்லாம் நினைக்காது. இது எலக்ட்ரிக்கல் ப்ராப்பர்ட்டி. It doesn't have feelings and all. Like humans, இதுக்கு ஃபீலிங்ஸ்லாம் கிடையாது. சரியா? அப்போ என்ன ஆகும்னா, it opposes the direction of the induced EMF is such that it opposes the cause that produces it. This is called Lenz's rule. Thank you so much. In the next video, we will learn more on electromagnetic induction. Thank you so much.